Hello my dear students, welcome back. Today I am going to teach science of class 8. So before starting today's lesson or today's lecture, let me help you to recall some basic ideas which will help you to understand today's topic. So you are familiar with materials like iron, copper, plastic and wood. So the question is, how do you distinguish metals from non-metals? Or can you name the materials which are metal? Out of this, can you name materials which are metals? Obviously, iron and copper are metals. Plastic and wood are non-metals. So the question is, how do you distinguish metals from non-metals? Or what are the criteria, or what are the properties which helps you to distinguish between metals and non-metals? So with this, I will announce the topic. That is, today's lesson is lesson number 4, and the name of the lesson is metals and non-metals. Metals and non-metals. And the topic which we are going to learn today is physical properties. Physical properties of metals and non-metals. So physical properties will help you to distinguish between metals and non-metals. So we are going to learn about the physical properties of metals and non-metals, which will help us to differentiate between metals and non-metals. And the physical properties that we are going to discuss today are luster, then hardness, then malleability or malleable. 4 is conductivity. 5 is ductility. And the last one is Sonos. Regarding luster and hardness, you have learned in class 6. The luster is the shining property of the material. Hardness is kan. So generally metal are luster, or they have the property of shining or lustrous, you can say. And generally metals are hard. Metals is langi amadi kalli. Non-metals na dull oil, aduga soft oil. Generally non-metals are dull and soft. So as you have learned about luster and hardness in class 6, today we will start with malleability. Today we will start with malleability. Metal matandadi metal na langi kalli, non-metal na dull oil mai haitare aduga soft oil. So malleability. So what is malleability? You can conduct an activity at your home. Take a nail and hammer or beat undang loroga your PM fu. Kind of furaganda, the shape of the nail changes. So mina fu matamda pakthok pasibu masigi properties of malleability kawi. And generally metals are malleable. So I'll write down the definition. The properties of metal by which they can be beaten into thin sheets. It's called malleability. And when you take sweets from the shop, or when you take edible items from fast food or restaurant, you will find your edible foods are wrapped using aluminium foil. Aluminium foil because aluminium, being a metal, can be beaten into thin sheets. Puro ka pakthon be masibo hoina malleable over kawi. Generally metals are malleable. Metals are malleable, or non-metals are not malleable. So the next topic is conductivity. Next topic is conductivity. Conductivity. So conductivity, we will discuss about the conductivity of heat and electricity. So when you take metal as an example, or UPM as an example, masi good conductor of heat and electricity. Or when you take a frying pan as an example, you will find the handles are covered with plastic, because plastics, being non-metal, they are a poor conductor of heat. The frying pan being metal, they are a good conductor of heat. And sabadu powder the plastic na kupshan mane. So generally metals are good conductor of heat. Are a good conductor of heat. Yumda yengu matamda wires electric wires si kaina sabano haragadi yumda si nari sina copper na saba ngakani aluminum ki sulai maybe they moi covering the metal or the heavy one is mai chingdana bani aduna. So we use wires made of metals because metals are good conductor of electricity. So generally metals are good conductor of electricity, and non-metals non-metals are poor conductor of heat and electricity. So the next point is ductility. Ductility. So what is the definition of ductility? Property of a material by which it can be drawn into wires. Wires ki mong da ching thok pe ya sana loro, for example. When you see the sana ilikka series sahalaga ching thoini. So material which can be drawn into wires, the yum the scenery by electric wires in si masi ductility have properties like ni. So the property of a material by which it can be drawn into wires, madu property to ductility kawi. And generally metals are ductile, and non-metals are not ductile. Non-metals ductility properties later. So the last point is sonorous. So the last physical property that we are going to discuss today is sonorous. So what is sonorous? Now could yet the metal laura could avoid the non-metal laura. Say for example, you take a nail in one hand and a piece of wood in the other hand. When you drop it from a height, when the material drop at the ground, so there is and you will find that there is a difference between the sound made by iron nail and that by the wood sound. The ringing sound. Ringing sound. Ringing sound metal. In case of a metal, you will find ringing sound when you drop it from a height. Masigi ringing sound sonorous. Masigi properties and generally metals are sonorous. Aduna metals ringing sound. This is also one of the physical properties of metal. So far we have discussed luster, hardness, conductivity, malleability, conductivity, ductility, sonorous, and these properties are all possessed by metals. So metals have these properties. Masi properties sing si yaro ke dekho ne kai ne habi are metal ni habi are. So now we will discuss the exception part. So far we have discussed that metals will have character or will have properties like luster, malleable, ductile, sonorous, and good conductor of heat and electricity. But now we will discuss some exceptions. Masigi exception si kaino harigadi metal singsina possess tawdaba physical properties singdu metal kharadadi possess tawta. When using any physical properties singdu follow tawta metal kharale. So we will discuss this under the topic exception. You will find this exception in page number 46 highlighted by yellow background. So some exceptions are given in your textbook. Then metals like sodium and potassium. Metals like sodium and potassium are soft. When I say physical property, we have discussed in the physical properties of metal that generally metals are hard. But you will find it sodium and potassium being metals, they are soft. Exception, or you can say it is the deviation from standard. And the second point which is given in your textbook is mercury being metal. Mercury being metal is found in liquid state. Liquid state generally metal see solid state hard hardness and is solid. So generally metals are solid. Mercury being metal, liquid state at room temperature. So these are exceptions. So I'll repeat. There are physical. We have discussed so far. We have discussed physical properties of metals, and in this topic exception, the point is that the difference is sodium and potassium being metals, they are soft. They should be hard according to the physical properties of metal, but it is deviated from the standard physical properties and they are soft. This is exception. And the second one is mercury being metal, it is found in liquid state at room temperature. So these 2 points are discussed under the topic exception. So the physical property, it means that physical property is not sufficient. So physical property is, it means, I'm repeating again, physical property is not sufficient to distinguish metals from non-metals because there are some exceptions. I repeat it again, physical properties are not sufficient to distinguish between metals and non-metals because there are some exceptions. So with this, I will summarize today's lecture. So the remaining part we will discuss in the next lecture. So far in today's lecture we have discussed luster, we have discussed hardness. I'll summarize what we have learned today. We have discussed malleability. We have discussed conductivity in terms of heat and electricity. Then ductility, then Sonos. So in case of metal, non-metal, we cannot say all metal possess these physical properties. We can say generally metals possess these physical properties because there are some exceptions. So generally metals are luster, non-metals dull, hard. Generally metals are hard, non-metals soft, malleable, not malleable. Conductivity, good conductor of heat and electricity, poor conductor of heat and electricity. Ductility, not ductile. Sonorous, not. So we can say, and we have discussed exception also. So exception means only physical property is not sufficient to distinguish between metals and non-metals because some metals, they do not possess these physical properties. That's why we should always say generally metals are luster, hard, malleable, good conductor of heat and electricity, ductile and sonorous. Generally, not all. So this is a summary of today's lecture. Now evaluation part. So in order to check whether you have understand the topic or not, you have to evaluate yourself. So in order to evaluate yourself, try to find the answer of these questions. Question number 1. Which of the following can be beaten into thin sheets? Which of the following can be beaten into thin sheets? Number A, zinc. Number B, sulfur. Number C, oxygen. Question number 2. Give reason why immersion rods immersion rod of liquids, immersion rod for heating liquids are made up of metallic substance. So in order to evaluate yourself, in order to check yourself whether you have understand the topic or not, please go through the lecture again and again, and you can take the reference of textbook also, find the answers of these questions. And you are not supposed to write the answer in your classwork notebook. This is just an evaluation. So the first question is, which of the following can be beaten into thin sheets? Options are zinc, sulfur, or oxygen. And question number 2 is, give a reason why immersion rod for heating liquids are made up of metallic substances. So both of these questions are related with the physical properties of metal. So you have to remember, or you have to know or understand physical properties of metals. Only after that you can give the answers of these questions. So with this, I conclude my lecture, and we'll discuss the remaining topic of lesson number 4 in the next lecture. Thank you.